let's have another go. Now here we've got an odd function. My drawing is a little bit wonky, but we can see that it's got a local maximum here at -3, 2, and a local minimum at 3, -2, and then it's got this sort of smooth shape. We don't know the equation, but we can just work off the shape to create a reciprocal graph down here. Now, let's start by looking at what the zeros are on the original graph. So we've got zeros at -4, 0, and 4. So that tells us that we'll need a vertical asymptote on our reciprocal graph at all three of those x values. So that's quite straightforward. Then we can reason about a few things. This is going onwards and upwards to infinity. So that tells us that as x gets bigger on the reciprocal graph, it's going to approach 0. But this is positive infinity it's heading towards. So it's going to be heading towards 0 here from above. In other words, it's still going to be positive. Now, that tells me that I've got some shape heading off like this and an asymptote going this way. All right. Now, what's it going to do as it approaches here? Can you have a graph just go straight at an asymptote and just sort of join it? No. By definition, an asymptote is just a section of the graph where the graph gets closer and closer to it, but it never meets it. So it's not going to be able to do anything other than go upwards like this. And I can tell it stays positive, it doesn't go down here, because if I look at this section of graph, it's all positive from 4 to the right of the 4. So that means our graph needs to be positive from the right of the 4. We can also see that the graph is positive here between -4 and 0. So I can tell that my graph's going to be up in this section. This part's negative, so we're going to be negative in the reciprocal as well. And this part to the left of the -4 is negative as well. So that tells me that over here, we're going to be doing the same sort of thing. Now, similar to the way I reasoned what was going on here, I can see that we're going towards negative infinity on the original graph. That means we're going to tend towards 0 from below on the reciprocal graph. So I've got something that's heading towards an asymptote out this way. But it can't be going upwards. This whole section needs to be negative, so it must go down like that towards this asymptote here. So now I've just got to figure out these two sections. Let's do this one first because it's positive y values. I've got a known point here, so I can reason that I can tell that when x is -3, the y value is 2. I can easily find the reciprocal of 2, it's a half, so that tells me that here I need to be going through -3, a half, so I've got a known point. I also know that the local maximum of one graph will be the local minimum of its reciprocal, okay? And that's because when we find the reciprocal of these y values, a really high one is going to have a low reciprocal and vice versa. I can also see that as we go down towards y values of 0 here, we're going to go upwards towards infinitely high y values on this reciprocal graph. And the same thing's going to happen here towards this asymptote, but the shape might be a little bit different. Now I can see here that this is not like an even sort of shaped hump that's symmetrical. It's more sort of skewed this way, isn't it? So probably my graph is also more skewed. So why not just take another point and have a look at where it is? It'll help give your reciprocal graph some shape. I can see here that this graph looks like it goes through -1, 1. That tells me that if the original graph, when x is -1, had a y value of 1, I can flip 1 upside down and still get 1. So it's going to go through that exact same point. So that tells me I need to head over that way and then go shooting up. Okay, so I've got something of a graph that sort of maybe goes up gradually and then goes shooting up, whereas over this side, it pretty much goes shooting up straight away. I'm going to have a similar shape over here because this is an odd function. So it's going to go through 1, -1, or something thereabouts. Okay, this graph is not great, but you see what I'm trying to do here. And it goes through this known point here. So when x is 3, y is -2. For me, when x is 3, I need to flip -2 upside down and have -1/2. So that gives me a point here that I know I need to go through. So now I can rough in my basic shape. Goes up and then goes shooting down very quickly. And I'm reasoning here that as we head towards 0, and here we're heading towards -infinity because we're heading towards 0, but it is negative. Does that kind of make sense? So now I've generated a reciprocal graph in blue just based on the picture that I was given of the original graph. This example is a little bit different. It's really quite a simple shape, and we can see that it's got one of those points of inflection in the middle there that we've already discussed before. It's got a horizontal asymptote at 2 and -2. So they seem to be my key sort of points, the horizontal asymptotes, and I've got the fact that it goes through the origin. So let's start with the origin. If you flip 0 upside down, you get something impossible, an asymptote. So that tells me that the zeros of this graph will become asymptotes of the one below. So I know I've got an asymptote here. Now, thinking about what's happening, as x gets bigger and bigger, y is approaching 2 here. So it's going to be really close to 2, but it's never going to quite get there. Now, flip 2 upside down, and what do you get? A half. So that tells me that this graph is going to approach a half, but never quite get there. So as x goes along, it's going to approach a half. So I need to put, let's say 2 is up here. It'll be 1. So this will be a half here. We're going to need minus a half as well. I've got minus 2 down there. We're going to need an asymptote at y equals a half, because that's the flipper of 2, if you like to think of it that way. Similarly, we're going to need an asymptote at minus a half, because as x approaches negative infinity, y approaches negative 2, so our graph is going to approach negative a half. Now to think about where this graph is going to sit. All right, let's have a look in here. What sort of y values have we got? Really small numbers, right? Like maybe a tenth or a fifth or a quarter or a half. Small fractions. When you flip those upside down, what do you get? Quite big numbers, right? So that tells me that the graph in these really low values of x must be up here. And we've got an asymptote, a vertical one here. So it must go shooting up like that, because these tiny fractions become giant numbers. Around about here we get to 1. And we've already seen that if you flip 1 upside down, you get 1. So about this far along, we get a value of about 1. So if 1's here, let's make it, what have we got? Here's 1. If we go along a little way, we're round about there. So that gives us a sort of known point. And then we've got this asymptote, so there's only one choice really, which is to go glancing towards it but never actually meet it. Now if we consider what's happening over here, well, we've got a negative section, so obviously our reciprocal graph is also going to be negative. We've got a negative tiny, tiny, tiny fraction, which when we flip it upside down, you get a negative massive number. So it's going to do the opposite of what this one did and come up from below from this asymptote. And we can see here a known point when y is negative 1, x is around about this far across. So we can sort of put our dot round about here of our known point and then go glancing off towards this asymptote. So we've got basically a hyperbola, but it's a bit of an unusual one. It's got this sort of no-go zone in the middle, and it approaches this line y equals a half, and over here, the line y equals minus a half from below.